solving special systems. So previously you guys have done graphing, substitution, and elimination, but we're talking about different cases today. So just to remind you, a system is like multiple equations. So this has two variables and it has two equations, and so we're going to be able to find out what the intersection is, or what there's a value for x and y that will hopefully solve for both of them. Okay, so we're going to solve this by graphing, and you want to be really good with your graphing calculator. So if you're solving by graphing, you know that the solution should be an intersection, right? It's going to be two lines, and they're going to intersect, and that's the solution. So if we go to our y equals, we have 1/2, make sure it's in a parentheses, x minus 4, and 1/2 x plus 2, and we're just going to graph them. And we have these two beautiful lines, and we can see that they never intersect, right? Never intersect, so there's no solution, right? There's never going to be a point of x and y where both of these are going to be true at the same time. It just doesn't exist. And you could sort of know this right away because these have the same slope, right? So you know they're never going to intersect. They're parallel. So let's look at number 2. So remember, in order to graph, we have to put them into slope-intercept form. So that's our first step. So for here, we're going to get 3y equals negative 5x plus 6. So I move the 5x. And then I'm going to divide by 3. So we have y equals negative 5 over 3x plus 2. So this is the first one. And then the second one, we're going to divide by 3. So we get y equals negative 5 over 3x minus 1. We're going to put those in our calculator. Negative 5 over 3x plus 2. Negative 5 over 3x minus 1. Okay, actually, wait. I think I messed up. Okay, so yeah, these also have the same slope, so there's no solution. Okay, what I think this problem was supposed to be was, I think it was supposed to be an example of infinitely many solutions. Okay, so let's do another example on the side here. 3. All right, if I have, let's say I have 5x plus 3y equals 6, and then I have 3y equals negative 5x minus, let's try, or plus 6. Okay, so it's very similar to 2. So the first one is again going to be y equals negative 5 over 3x plus 2, and the second one is going to be y equals negative 5 over 3x plus 2, right? So they're the same. So when they're the same, if you graph it, it's almost redundant, right? You graph it, and it's going to be the same line. So you have the blue line, and then the red line goes right on top. So when it's the same line, this is infinitely many solutions. Infinitely many solutions. Right, so pretty much if I look at this equation right here, I can put any value of x and y, and it's going to be the same. Right, I could do 1 and 4, and they'll work for both of them. I could do 2 and 2, 2 and 2. So since it's the same line, it doesn't matter what points I put in here, they're always going to work. Right? For 1 and 2, no matter what points I put in there, it's never going to work. So right below, there's like a summary right here. So these are the possible outcomes when you graph. There is one solution, right, where we have the lines, and they have different slopes, which means they have one intersection point. Right, this is our solution. Right, so before when we just had one line, our solution was the x-intercept, right? We could do a parabola, and we had two solutions, or we had a line, and we had one solution. But when there's multiple lines, the solution is now where they intersect, right? We have this other situation where we have parallel lines, and they have no solution because they never intersect. And then we have a situation where it's the same exact line, and it's infinitely many solutions, because they always intersect. So these are the three different things. The special systems are this no solution and the infinitely many that we haven't seen before. Okay, so let's look at 3 and 4. Remember, it says be sure to solve for y first. So why don't you pause the video and work on these on your own. All right, so for this one, we solve for y. This one's already done. This one we're going to add 3x to both sides. So we get y equals 3x plus 1. And if we graph it, we're going to see that we have something like this and then something like this. So I don't want to do my calculator, but you should be able to tell because it's the same slope. Right? We have no solution. They never intersect. And then for this one, this is already in y equals, but this one we have to divide everything by -2. We get y equals 4x minus 1. We see it's the same exact equation, so it's infinitely many. Same line. All right. Backside, almost done. Okay, so with substitution and elimination, this is how you do it algebraically. So substitution, remember substitution is you solve one of them for one of the variables and you plug it in for the other. So this one, right, our step 1 was already done. And this is in 8.2. Substitution is B08.2, and this is B8.3. So step 1's already done, right? We already have y equals, and then we're going to sub it in. So I'll make it purple. So I have negative 16x plus 2 times 8x minus 1 equals negative 2, right? So I'm subbing in my y with this new equation that I made, and now I just have one equation and one variable, right? There's just an x, it's one long equation, so I can solve for it. The issue with here is that I had two different variables, so I couldn't solve for it. So I have negative 16x plus 16x minus 2 equals negative 2. Negative 16x plus 16x combining like terms at 0. So I have negative 2 equals negative 2. So this is always true, right? This is always true. So infinitely many solutions. So this is a little, conceptually, this is a little harder to grasp than the graph. Like if you look at the graph, it's pretty easy when something is infinitely many. It's the same line. But when you're looking at it algebraically, you need to think like, okay, if the variable goes away and it's just giving me this fact that's always true, then it's probably like the same line, right? And we're going to have a chart at the bottom to explain it, but you want to be able to understand both. You want to be able to understand the graph, and you want to be able to understand the algebra and the concept, right? Like the reasoning behind the math. And then elimination. Elimination is from 8.3, so we're going to multiply things to cancel them out. So for this one, it would probably be easiest to multiply this whole thing by 6 so that we can cancel out this x. So we get, the first one is 18x plus 6y equals 24. And the second one, we're going to do 18x minus 6y equals negative 12. So we just multiplied everything by 6. And now we can add these all together to eliminate. So we get 0 plus 0 equals 12. So 0 equals 12. And for this one, off the bat, you know, like this is impossible. This is impossible. This is like when you live in a different dimension and you're like 2 plus 2 equals 5, right? This isn't true. 0 does not equal 12. If someone said that to you, you'd be like, you're gaslighting me. So this one is no solution. So if we were to look at this on a graph, it would be the same slope, right? Same slope. And this would be same line. Okay. So just a summary, little cheat sheet. Hopefully you can not memorize the chart, but just know it. But this is a good way to keep it organized. Some people like visual stuff. So we pretty much have our three solutions, right? We have no solution, which is our parallel lines. We have our unique solution, which is our intersecting lines. And we have our infinitely many solution, where we just have one line. So this is what it looks like graphing. And then if we're doing it algebraically, this gives you something that is never true. This gives you like an x equals and a y equals. And then this gives you something that's always true, right? The sides are equal. So just a little cheat sheet, and that's it.